This presentation is delivered by the Stanford Center for Professional Development.
All right, let's get started on our next great topic then. And today I should say, I think it's tonight because like the lights are on. It's actually daytime. So today, there's a whole new concept that we're going to be getting into called an array. Okay? And all an array is basically a way to keep track of a whole bunch of information at once. So what we've done so far in class is like when you want to keep track of information, you had some variable, and you had like an int, or you had a double, or you had a g-oval, or whatever it was, and you kept track of some like small piece of information. But in the real world, really what you want to do is keep track of a whole bunch of information. Like say you're going to take your midterm. We would want to keep track of all of your midterm scores. And it would be a real pain, for example, to say int midterm 1, int midterm 2, int midterm 3. You can just see how monotonous it is. And like by the time I got to like int midterm 150, you'd be ready to kill. But we couldn't stop then because we'd have to go up to like int midterm 325. Right? And so we just don't want to do that. And computers are really good at dealing with lots of information. So the way they allow us to keep track of a whole bunch of information at once is something called an array. And so the two key concepts for an array is that an array is ordered. So it has some natural ordering, and that means we can refer to the elements of the array using some index based on that ordering. And it's also homogeneous. Homogeneous, which means that everything in the array that we store is of the same type. So we can have an array, for example, that stores integers, and we could say, hey, we want an array that stores 500 integers. But it's only going to store integers. It's not going to store a couple integers and a couple doubles and some strings. All the types are the same, so it's homogeneous. Okay? So how do we actually create one of these things? We'll erase some announcements. We'll slide this puppy over here. It's actually the first time I'm sliding boards around. And the reason why I always hesitate to slide boards around is all it takes is one really nasty time to get your finger crushed by a board, and you never want to slide boards around again, because then you can't write for a couple days, and it's real fun to do class, especially for you with the left hand. All right, so how do we actually declare an array? First, we specify the type of the thing we want to have in that array. Then we have an open bracket, closed bracket. That's going to indicate to the computer that this is an array of this type int. Then we give it a name. So let's just call this, I'm going to call it my ARR for my array. Okay? And then what we need to do is basically tell the machine, hey, create some space for the array for me. Okay? So the way we specify that is we use our friend new. Then we say the name of the type again, which may seem a little bit redundant because we just said it over here. But the reason why we have to say it over here again is because we need to tell the machine, hey, I want you to set up some space for some new integers. And the place I'm assigning that to is an array of integers. Okay, so these two types over here actually generally need to match, but you do need to have that redundancy. And then the thing that we specify over here is we actually specify what the size is of our array. So for example, we could have 5. So what this is actually giving to us is it's giving us an array of 5 integers. Okay? And the way you can actually think about this is an array is basically like a big list that has a bunch of cells in it, or what we refer to as the elements of that array. Okay? So this is my array, my ARR, and it's space for 5 integers. And the way we refer to these particular integers, or the elements of the array, and each one of these boxes holds one integer, is they're indexed, because this is an ordered collection. Right? It's homogeneous because they're all integers, it's ordered, and it's indexed starting from 0, because as computer scientists, we always start counting from 0. So if I ask for an array of 5 elements, they're actually indexed from 0 up to the size of the array minus 1. That's life in the city. Just like a string, right? The characters in the string were 0 up to the length of the string minus 1. Same idea with an array. And each one of these things in it is storing an integer. And when you create a new array, the values actually in the array get initialized. They get initialized to whatever the default is for that type. What does that mean? Well, it means for things like integers, the default value is 0. For things like booleans, the default value is false. And there's a whole list of what the default values are. But we're going to just stick with integers right now. So all these things start off with the value 0 in them. One of the niceties Java gives you the arrays initialized. So if you've worked with other languages like C or C++, this is one of those things you have to just let go, because the syntax is different, the initialization is different. Let go of your old C ways and just adopt the happiness that is Java. Okay? So how do I refer to these individual elements? The way I refer to the individual elements is through the indexes. Okay? So I could say something like my ARR 0. And I put this inside square brackets. So it's square brackets over here and square brackets over here. And what this is now referring to is this particular cell, which stores one integer, which means I can use that just like I would use a variable of type int anywhere else in my program. I can assign to it. I can use them in expressions, whatever the case may be. So if I say my array equals 5, what it's actually doing is just sticking the value 5 into the cell. Okay? So any questions about that? Hopefully fairly straightforward. All right, so the thing you want to think about for these arrays, and what makes them kind of funky, is first of all, I can get a whole bunch of values very quickly just by specifying the size of the array. The other thing is that this little index that's in here doesn't necessarily have to be a constant value like 0. I could actually put a variable in there. So I could, for example, have a for loop that goes through all the elements of my array. For int I equals 0. I, in this case, I'm just going to say is less than 5, which is the size, but we'll get to how we actually want to deal with that in just a second. I plus plus, and then inside here I'd say my array sub I, which is that particular ith element. Maybe I want to read this, for example, from the user, equals read int, and I'll just, put the little question mark to ask the user for a value. And so what this does, it goes through and essentially asks the user for 5 integer values and stores them in the indexes of the array from 0 up to 4. Okay? So one quick loop does all the work, right? If I had 300 values, I'd change this to a 300. I'd change this to a 300. I'd be good to go. That's all I need to change in my program. That's kind of the power of arrays. Okay? So the more general form of arrays, this is how we might actually use them, and in this case I'm just thinking about integer arrays. The more general form of thinking about arrays sort of looks like this. Ooh, a lot of chalk dust. You'll notice here we'll just map it to kind of the general form. This is the type that you want to specify. Okay? Then we have open bracket, close brackets, which are angled. Then you have the name of your array. Then you say equals new, and you specify the same type again, and inside brackets you have the size. So that's kind of the general form. So we could have an array of doubles, right? We could have an array of booleans. We could have an array of strings, for example, by saying string bracket bracket. I'll call this slist for string list equals new string. Oh, let's say I want 100 strings. Okay? Life is pretty easy. All right? So any questions about that? All right, hopefully it's all fairly straightforward. Now, the other thing that's kind of easy is that I should mention is you can have, as you might notice, a string as an object. I could have an array of, for example, g ovals or g rects. So I could actually say something like g oval maybe is my type, and then I'm going to have an array of these things, and I'll call this, my circles, because I'm just going to have a whole bunch of these ovals that maybe represent circles. And then I'll say new g oval, and here's where things get a little funky. I say new g oval, and then let's say I want to have 10 of these things, I put a 10. Notice this looks different. Even though I use the new, it's different than the syntax for creating one new oval, right? If I wanted to create one new oval, I would say something like, I'll put it down here, g oval, and I'll just call this O for oval, equals new g oval, and then I would give it the parameters for the constructor, like some original xy location and some size, maybe 100, 100. What this is doing is creating one object of type g oval and assigning it to the value O. What this is doing is creating space for 10 g ovals, none of which have been created yet. Okay? So what does that actually mean? Let me make this a little bit smaller so I don't have to draw 10 boxes. I'm going to make this 4. Okay? But same effect. When I do this declaration, what I now have is this thing called circles, which is an array. It's an array that's got 4 cells in it. Okay? And each one of these cells is basically going to be able to store a g oval. But each one of these cells right now doesn't actually have a g oval in it. Why? Because I haven't created a new g oval in each one of those cells. Each one of these cells or elements, all it has in it is the ability to store a g oval. It's kind of like if you just said g oval, and I'll call this empty. Okay? What happens when I say g oval empty? I get this thing called empty over here, which is space for a g oval, but I haven't done new on it yet, which means this thing doesn't actually point to any object that is a g oval. Its value, for example, is null. right? There's no actual G-oval there. I just say, hey, get me the box that's going to store a G-oval in it, but I'm not actually putting in a G-oval in it yet. So when I do this declaration, I'm essentially doing the same thing as this, except rather than getting one box, I'm getting 4 boxes. So each one of these boxes to begin with has a null in it. Okay? So I have space to store 4 G-ovals, but I have not yet constructed the G-ovals. So if I actually want to construct the G-ovals, I'm just going to make use of this little line right here. I could say, for example, circles sub 0 equals new G-oval. And what this will now do is say, hey, this is circle sub 0 over here. Go and create some new oval and stick it in that box. So now it actually has an oval to deal with. Okay? Or if you want to think about it from the memory point of view, what really is happening is this is some pointer somewhere that points off to some piece of memory that's storing the information for an oval. Okay? So any questions about that? That's a critical distinction between creating the array, which is just creating the space for essentially these pointers or references to objects, and actually creating the object, which you still need to do. You can just create objects in each one of the individual elements of the array if you want to. But if you just create the array, you don't actually get space for the objects themselves. You just get space for the references to the objects, much in the same way you do when you just declare a variable of some object type.
Is there a more efficient way if you had an array with like 100 and something spaces to put something in spaces?
To create new ovals, for example?
Yeah, if you want to put in.
Absolutely. So let me erase this, and I will just put in one extra line up here. For int I equals 0, I less than, in this case, 4 I plus plus, circle sub I equals new G-oval. So that's the beauty of arrays, right, is the fact that you can use them with objects just in the same way you could do them with ints. And so you can go through and, for example, construct all your objects, and now you've created a whole, all these ovals are the same, size, right? They're at 0, 0, and they have size 100, 100, but they're all distinct ovals. So what I've actually gotten in here is this points off to some oval, and this points off to some oval, and they're all distinct ovals. They just happen to have the same dimensions. Okay? But that's one way I can create all the objects very quickly if I actually want.
Can you put an oval in an array and then you change the oval, like set something different? Does it change in the array? Like, can you refer to it?
Yeah, so once I've created all the ovals, I have all these pointers. You're saying like if I pass it to a function? Yeah, the thing about objects is anytime I pass an object, I'm passing a reference. So if I change the object that I'm referring to, I'll always be changing the real actual underlying object. The important thing that we'll get to in, about 10 minutes is the fact that when we get into primitive types in arrays, I can actually pass an array of primitive types and change the primitive types in the arrays, which I couldn't do before. So that's part of the beauty of arrays. Okay? So I'm going to go give you a brief digression on one topic before we kind of launch into the next thing. And this brief digression is this operator that you've actually been using the whole time with tact and verve. As a matter of fact, we just used it on that board over there. And now you're old enough to sort of understand what it really does. You're like, but Maron, I thought I knew what it did. This little operator called plus plus. It was so nice. I just added one. I used it since the days of Carol when I had for loops in Carol. I had a plus plus. I didn't know what it did then. Then you told me what it did and life was good. I could add one to things. Now I'm going to tell you what it really does. And you're like, it does something besides add one to something? Yeah, it's just very tiny difference. The thing with this plus plus is there's actually a bunch of different places I can put it. You're like, yeah, I can imagine some places I'd want to put it, Maron. Yeah, no, it's not going there. All right, so here's x equals 5. That's just terrible, and it's on video. All right, so I have x. It has the value 5. Now somewhere in my program I come along and I say, you know what? Let me draw my x5 over here so I can have more of my program. My x5, I say x plus plus. What is that doing? It turns out plus plus is actually a method. You're like, whoa, it's a method? Yeah, and it returns something. You're like, oh, that's even weirder. So what it does is it adds 1 to this variable. Okay, so it turns it into 6. But this is actually returning a value, and the value it's returning is the value of this variable before you did the plus plus, so it returns a 5. Okay? In the past, we just never used that value. We said like I plus plus, and it added 1 to I and said, oh, here's your return value, and we said, yeah, we're not assigning that anywhere. We don't actually care. But we could actually assign it somewhere. Okay? So I could actually do something like, say, int y equals x plus plus, And so y will get the value 5. X will start off as 5. I'll add 1 to it. It'll become 6. And you might think, hey, isn't this whole thing 6 now? Doesn't that get assigned to y? No. When I put the plus plus after a variable, I get back the old value of the variable. This form is what we refer to as a post increment. Why is it post increments? Because the plus plus comes after. That's where the post comes from. And it adds 1, so it increments. So the way you can think of it is I add 1, but after I return a value. Okay? So you might say, hey, Maron, if there's a post increment, isn't there also a pre-increment? And you would be right. And the way a pre-increment looks is we take our friend the plus plus and we put it before the variable. So we say plus plus x. Okay? In terms of the effect it has on x, it's exactly the same. It adds 1 to x. So when I say x equals 5, I put in the 5 here. Then I say that looks like just a whole bunch of, let me make that a little bit more clear. I just looked at that and I'm like, I can't even read what that is. Plus plus x. So what it does is it adds 1 to x, and it returns the value after adding 1. So it actually returns a 6, and that's what gets assigned to y. And this is called a pre-increment. And the reason why it's called pre-increment is I do the incrementing first. I add the 1, then I return the new value. Okay? So any questions about that? And you're like, but Maron, why are you telling me about this? And the reason why I'm telling you about this is that this little form, this x++ form, and the fact that it returns a value actually gets used a whole bunch with arrays, and I'll show you some examples of that. But you need to understand, that's why you need to understand what it's actually doing. It's adding 1 to the value x, but returning the old value when I do the post increment. And that's the version you usually see with arrays. Okay, but now you know. So any questions about post increment versus pre-increment? Alrighty, then let's actually put a bunch of this stuff together into a slightly larger program. And as part of that slightly larger program, we can discuss a couple more concepts that come up with arrays. Arrays hopefully aren't too hard. Like in the past, every time I've taught arrays, like it seems like, yeah, most people generally get arrays and they generally work the way you think they would work. So hopefully you should be feeling like okay with arrays. If you're feeling okay with arrays, nod your head. If you're not feeling okay with arrays, and it's okay if you're not feeling okay with arrays, shake your head. Alrighty, let's go on then. There's this notion of the actual size of the array versus what we refer to as the effective size of the array. Okay? The notion of the actual size of the array is this is how big I've declared the array to be. So when I set up my array here, the actual size is 5. Okay? It's how big it's declared. The effective size is how much of it I'm really using in my program. So the idea is how much are you really using? Because sometimes what you do is you say, hey, you know what? I'm going to have some program that computes the average midterm scores. But I don't actually know how many people are in this class, frightening as that may be, right? And I probably won't know until I see how many people actually take the midterm, because some people might withdraw or whatever at the last minute. Hopefully you won't, but sometimes it happens. So when I'm writing my program, I can't just stick in some value a priori that I know. One thing I do know is there's probably less than 500 people taking the exam, so I can set my actual size to be 500. And then there's some number of midterms that will actually grade and I'll have the scores for, and that's how many I'm really going to be using. That's going to be my effective size. And I need to keep track of this to distinguish it from this in my program. So let's write a little program that actually does that. Oh, I think I can fit it all on this board. Let's try anyway. So what I'm going to do is write a program that basically asks the users to enter values until they give me some sentinel to stop. Okay? So my sentinel, private, static, final, and you have to say it kind of like you're singing a dirge. Sentinel equals -1, because I really hope no one's going to get a -1 on the exam. I don't know how you would do that. It's like you don't do any of the problems and somehow you manage to like upset the instructor, right? It's just like, okay, you're getting a -1. Thanks for playing. I used to give 1 free point if you spelled your name right and someone got it wrong once, so I don't do that anymore. No joke, it really happened. I think just too much stress or something like, or maybe I couldn't read the writing, but I was like, that is not the name. All right. So one of the other things that we're actually going to do is keep track of how large the array is going to be in its declared size. So I'll keep track of some maximum size, which I'll just call max size. And maybe I'll set max size to be equal to 500. So I know I'm going to have at most 500 scores that I'm going to store. And so when I'm going to create my array, I'm going to create an array whose size is max size, and then keep track of how many elements I'm actually using. So in my program, right, so let me put this in public void run. And inside here, what I'm going to say is I'm going to have some integer array that I'm going to keep track of. Actually, there's no space in here, so let me just rewrite that. Some integer array, and I'll call this midterm, or I'll just call it mid to keep it short. It's going to be the midterm scores. And what this is I'm going to declare basically a new array of integers that size is this constant over here, max size. Okay, so I set that up, and now I get an array of 500 integers just created for me, and life is good. And I say, oh, that's great, but I don't know how many scores I actually have, so I want to keep track of the effective size to remember how many scores I have. So I'm going to keep track of an extra integer in here called num scores, and I'm going to set that equal to 0, because to begin with, I don't have any scores that the user has given me. Okay, now I'm going to have a while loop that's going to read in scores from the user. So I might say while true, because I'm going to basically keep reading scores until the user gives me the sentinel value over here, and that indicates that I should stop. Int score, so I'll read one score at a time, equals read int, and I'll ask the user for a score by just putting in a question mark. Then I say if that score is equal to the sentinel, then I'm done, right? They just gave me a -1. I know that's not a real score, so I can just break. But if they gave me a score that was not a -1, so it's some valid score, okay, then I want to store that in my array. And so the way I'm going to store that in my array is I'm going to say mid sub, and here's where I'm going to get funky with my plus plus operator, num scores plus plus. Let me write that a little more clearly. Num scores plus plus equals score. And there's the end of my while loop. Okay, and then my program will go on after that. So what's going on here? Okay, and the reason why I showed you this is you will see this all if you look at real Java programs. This kind of thing happens all the time where you do a plus plus inside the index for an array. So what happens? This array gets set up. It's got size 500. So whoosh, 0, 1, 2, 3. I won't write it all out. We have a big break in here. This is 499 over here. All right. So we have this huge big array, and num score starts off as 0. So here's num scores. I'll just abbreviate NS for num scores. It comes in and says, read some score from the user. So it gets some integer, and I say, oh, someone got 100 on the exam. Wonderful thing. Is 100 equal to -1? No. So I don't break out of the loop. And now I'm going to set midterm sub num scores plus plus the score. So what's that going to do? First, it's going to come over here and say, what's score? Because it always evaluates the right-hand side first. That score is 100. That's all you need to do. Where am I going to store scores? I'm going to store it over here. How do I evaluate this? I say, OK, I'm going to store it somewhere in my array mid. Here's the array mid. Which one of these cells am I going to store it into? I'm going to store it into the cell given by num scores plus plus. So what do? This is a post increment. I add 1 to num scores. Num scores now becomes 1. But what value actually gets returned there from the plus plus? 0, right? That's a social all around. Except like there's 3 pieces of candy right there. It returns a 0, so mid sub 0 is what gets score. So this gets 100. And I've gotten the nice effect where I've gotten the score stored in the location I want, and at the same time I've incremented num scores to tell me how many scores in this array have actually been entered that I care about. Okay? That's why you see this all the time with arrays, especially in Java or other Java-like languages like C or C++, because it's a shorthand that's so common to say, yeah, the next time you get a score, put it in the next available spot and increment the number of scores you have. So the next time I go through the loop, it gets another score. Let's say someone got a 30. Sorry, just didn't work out. Study. You get the 30. It's not equal to the sentinel. Where am I going to store that? Mid some num scores plus plus. Num scores is currently 1. I add 1 to it, I get 2, but I return the old value, which is 1, and so I stick in the 30 in mid sub 1. Okay? So num scores here is the effective size of my array. It's how many elements of that array I actually care about using. So if I want to now go compute the average of all the scores, I'm not going to go through all 500 elements, because not all 500 elements have valid scores that I care about. I'm just going to go through num scores number of scores, the effective size of my array, even though I might have some declared size that's larger. Okay, so any questions about effective versus actual size or using this plus plus operator to keep track of things? Ah, good question. Is that what you were going to ask back there too? Yeah, what if someone just enrolled a whole bunch of times in the class? Yeah, I can't get you. That's an excellent question. What do you think would happen if I try to access, say, mid sub 500? You're like, I don't know, I get candy? No. You get an exception. Okay? But this time, it's not a little exception. You're getting a big honking exception. And so if I'm getting ready to throw this out somewhere, it's going to be bad. It's going to hurt. Okay? So that's an exception you, first of all, you don't want to get. And second of all, if you get it, you probably don't want to deal with it in your program unless you're writing some very advanced program. You want to figure out that there was some problem with your logic and go fix the problem with the logic. Right? It's kind of like eventually someone will get this exception somewhere and they're like, oh. I am disturbed by your lack of bounds checking on the array. You know, it's just one of those things where you want to check. Don't worry, I'm not going to give the whole lecture like this, because if I did, I couldn't see after a while. But it's an evil, evil exception to get. It's not that bad, but you should be careful of that exception. It's a big one, not to be confused with the small exceptions. Thanks for asking. Yeah, not a plant. Valid question. Figured someone might ask it. So let me show you an example of how we actually do deal with that in a program. Okay? So in a program, we can get around this in some slightly more interesting way and avoid the exception. So here's a more complicated version of the program we just wrote. Rather than setting a maximum size to be a size that's declared as a constant, I'm actually going to ask the user for a maximum size. Because let's say maybe I want to run this program for 106a and then I want to give the program to some other instructor somewhere and they can run it for their own class, and they don't want to have to recompile the program. They just want to start the program and say, yeah, I don't know how big my class is either, but its maximum size is like 4,000, right? It's like econ 1 or something like that. And so just give me an array. So here's one of the things that's interesting. I have int max length, and I'm going to ask the user for the maximum size of the array rather than having it set as a constant. I now declare my array, I'll call it midterm scores here, to be a size that's this max length that's given to me by the user. If you've programmed another language like C or C++, at this point you should be going, oh, Marin, I couldn't do that in C or C++. And if you never programmed in C or C++, you should be going, yeah, Marin, I don't care what you can do in C or C++ because I'm programming in Java. And Java allows you to declare an array like this where the size is actually something that's dynamic, that's only known at runtime when the user enters it. Okay? Here's my number of actual scores. That's going to be my effective size for the array, how many elements of the array I actually care about. And now, rather than having a while loop, which may allow me to just potentially go off the end of the array, I'm going to have a for loop. And this for loop is going to count up to the maximum length. So it's going to guarantee if I ever get to the maximum size of the array, I'm going to stop asking the user for any more values because I will have exhausted the for loop. But if I haven't yet exhausted the for loop, what I'll do inside here is I will get a score from the user. So I'll read in the next score into midterm score. If that score is the sentinel, I will break out of the loop. If the score is not the sentinel, then I will increment my number of actual scores and iterate this over and over. Okay? Now, the interesting thing here is if the user actually enters the sentinel before they get to filling in all the elements of the array, the max length, I break. Break always takes you out of the closest encompassing loop. So this whole time you've been using break with, for example, while loops. This will actually break out of a for loop. You can break out of for loops as well. It's not the greatest style in the world, but sometimes in rare occasions like this, it actually makes sense because you want to say, the most I'm ever going to count up to is max length. Guarantee me that I'm not going to go any higher than that. Otherwise, I'm going to get the Darth Vader exception and life is going to be bad. But I might break out earlier if the user actually gives me the sentinel. Okay? And I'll only increment num scores if they didn't give me the sentinel. So I'm not going to count num score. I'm not going to count the sentinel as one of the values I actually care about. Even though it gets stored in the array, I'm not actually going to say that's a valid value because I break out before I actually increment num scores. Okay, any questions about that? If they enter a negative score for the maximum, well, try it and see what happens, right? It's never going to happen in real life. And so if you're really interested, I might just peg her because it makes me angry. I can't reach you, but I'm going to keep trying. Try it yourself and see what happens. It'll probably give you something that won't work, right? So what's something else that I want to do? And I'll get to that right now, but let me do it on the board before I show it to you in this program, because there's something else I might actually want to do in the program. What happens if I pass an array as a parameter, right? So this whole time we've been talking about arrays, we sort of had the array inside your run method, and life was good, and we were like, oh, array, yeah, I can do all this stuff with it. What if I want to pass an array, which is a common thing to do, as an actual parameter to a function? Okay? So let's say I have public void run. Inside here I have int, bracket, bracket, I'll call it ARR for my array, equals new int 10. So I get an array of 10 elements. And now I want to pass this array. I want to say, hey, Meron, rather than reading in all the values from the user in your main program or in run, I want to decompose the program. I want to have some function that actually reads all the values for me. Can I do that? Yes, you can. And so let me have some method called readArray, and what I'm going to pass to it is the array. When I pass an array, if I want to pass the whole thing, I just specify the name of the array. I do not specify an individual index on the array, because if I specified an individual index, I would just be passing a single element of the array, which would be a single int. If I want to pass the whole array, I give the name of the array with no other brackets. Okay, so this is going to pass a whole array to a method. So somewhere down here, let's just say that's the end of my run method. Maybe I have some more stuff in here. I have private void read array. And read array is going to take in some parameter. How do I specify a parameter array? I say int bracket bracket. That indicates the thing that is getting passed to me is an array of integers. Okay? And then I give it a name for the parameter. Here I'll call it A. Okay, just to distinguish it from ARR. All right, so inside here I get A, and so I'm going to have some for loop inside here, for int I equals 0. And you might say, oh, Meron, how do you know how big the array is? How do you know how many elements to ask the user for, right? Because you just passed the array. Where's the size of the array? You didn't specify. If you had it specified as a constant like you did before with max size, then I could refer to that constant over here. But you didn't specify it with a constant. So what do? I would normally give you concentration music and let you decide. But in fact, arrays, and this is one of the nice things about arrays in Java, they carry around their size with them. Okay? So what I can say is array.length. Okay? And the funky thing here, to distinguish it from strings, when you asked a string for its length, you put in an open brace or an open bracket or open paren, close paren. Here you don't specify open paren, close paren. Length is actually some internal variable of an array that is public, so it is available to you. So you're actually referring directly to this public variable of the array. So array.length, I want to say actually I is less than array.length. So let me set this to be 0. I is less than array.length, I plus plus. And so if I pass arrays of different length here, their declared length, right? I don't know what its effective size is. Its declared length is 10. And so what I might do inside here is say a sub I equals read int to get an integer from the user. And that's supposed to be a question mark inside double quotes. Now you might see this and say, oh, Meron, I thought you told me when I pass around primitive types, I get a copy of the primitive type, right? So when I pass an int, I get a copy of the int. And if I try to muck with that int, I'm just mucking with the copy. And so when I return to my calling, the location from where I called that particular method, that value hasn't changed. Yeah, that's for a primitive type, not for an array, even if the array is of primitive types. So the thing you want to think about passing arrays is arrays always get passed by reference, just like objects. If you pass an array, you're getting the actual array. Because it says, hey, you know what? Arrays are big. I don't want to copy 10 integers. I'm lazy. I'm just going to let you know where that array actually lives in memory. And so when you make any changes to that array, you're actually changing in memory at the place where this array actually lives. So it does it mainly for efficiency reasons, right? Because if this was an array of 1,000,000 elements, if you got a copy, it would have to copy 1,000,000 elements every time you made this call. Rather than copying them, it says, hey, I'm just going to let you know where those 1,000,000 elements live. If you want to mess with them, you mess with them. You're going to change the actual one. If you don't want to mess with them, then don't mess with them.
A.length is a variable. It's public. Can you change the length in the middle of code?
You shouldn't try.
I was wondering if that would happen if you actually did that.
Yeah, I wouldn't encourage you to try it. I would just say don't try it. It's a bad time. But if you really want to see what happens, try it. It's never something you would want to do.
Can arrays be IVARs?
Yeah, arrays can be IVAR. So if you want to have an array declared inside a class and actually store an array inside a class, that's perfectly fine. So arrays you can use just like any other variables. You just get a whole bunch of stuff. Okay? So, but the important thing is any changes you make to the array, the changes persist. Arrays always get passed by reference. Okay? So at this point, you could also say, hey, Meron, that means if I wanted to change around some integer and I just had a single integer, could I actually have an array of one integer and pass that array of one integer and change that one value and I could change an integer that way? Yeah, you could. It would be horrendous style, but you could do it. Okay? So don't do it in this class and don't ever do it as a software engineer, because if you do this as a software engineer, people will look at that and say, where did you learn this? And you'll say, oh, that Sahami guy at Stanford told me this. And then they'll come and hunt me down and kill me. And that's bad. At least for me. May not be for you. Don't do it. It's not how we try to pass integers by reference.
Can you make arrays of arrays? Like if you wanted to have all of our test scores divided up by test?
You can, and you're actually one day ahead of me. So next time we'll talk about multi-dimensional arrays, where you can have arrays of arrays of arrays of arrays. And it can just, till the cows come home. You can have like 4-dimensional arrays. You can have like 12-dimensional arrays and just expand your view of the universe. Yeah. It's like string theory with arrays. Yeah, the other dimensions are just wrapped so tightly you can't actually stick integers in them. But that's not important right now. Yeah, there's like a few string theory people who are like, oh, that's funny, Meron. Everyone else is like, what? All right. So, yeah, not that I'm a string theorist, but I'd like to play one on TV. All right. So, what else can we do with arrays? If arrays, when we pass them around, we're actually passing references to arrays, that means other funky things are sort of possible. So let me show you another example of something that's possible if we return to our program. This one's not so funky. This one just says, hey, what I want to do is after you give me all those scores, I want to compute an average score. So I'm going to have some method where what I want to pass to this method is the midterm scores array that I had before, right? That's just this array that we declared up here. And I also want to pass to you the actual number of values that I'm using, the effective size of the array. The reason why I'm doing that is because if I don't pass you the effective size of the array, you don't know the effective size of the array. The only thing you know that the array gives you is its declared size. It doesn't keep track of, oh, which elements you're using or which elements you're not using. It says, hey, I know I'm this big. And if you're not using the whole size of me, then you do need to pass the effective size. So inside compute average, it's getting passed an array of integers, and it's getting passed the number of actual scores that we care about. And it just goes through a loop that counts up all the actual scores, adds them to this thing called average that we're sort of adding up as we go along, right? So it's adding all the individual elements of the array to average. And then when we're done going through all the elements we care about, we just set average equal to average divided by num actual scores. And because average is a double, it does real value division, so we get the average and we return the average here. Okay? And so all this prints out its average score, and then it will actually print out what the real average of those scores were as some double. Okay? So important thing to keep in mind, even though you get this facility where you know the declared size of the array, sometimes you still need to pass the actual, effective size if you're not using all the elements of your array. If you're always guaranteed that you're always going to have, yeah, this is the Olympics and there's always 7 judges and I know it's always going to be 7 and that's just the way it is unless there's some kind of payoff scandal, then you know it's 7, the declared size and the effective size are the same. Okay? One of the other things I can also do, now in this case, notice in this, it's array's example case, I didn't actually change any of the values inside the array. Okay? Even though I didn't change any of the values, the array still got passed by reference. So I still had the real array. If I changed any values, they would have persisted. But I still get a copy no matter, or still always get the actual array. I don't get a copy whenever I pass it, whether or not I change the values. In most cases, you don't change the values, which is why it's actually more efficient to not give you a copy to give you the actual thing. Sometimes what I might want to do is say, hey, you know what? I want to swap 2 values around. And so you might think, hey, you know what? If I have some array, here's some integer array that I declare here that's got 5 elements in it. And I set its first 2 values to be 1 and 2 respectively. So array sub 0 is 1, array sub 1 is 2. Okay? Then I say, hey, I want to swap the 2 values. So I have some function that Meron wrote for me, some method called swap elements buggy. Why did he name it that? Yeah, not because it's a little baby that's inside a little stroller that we push around that in the days of yore we used to call a buggy, because it's got an error. This is not the way you want to do it. And I just wanted to make it explicitly clear, so this is the buggy version. The buggy version says I pass in these 2 elements of the arrays as the 2 parameters, which means when I want to do swap, here's the buggy version. The buggy version says, hey, I get passed an integer x and an integer y. Why do I get an integer x and an integer y? Because the elements that I passed in were array sub 0 and array sub 1. Those are integers. They are primitive values. I'm not passing the whole array. I'm passing individual elements of the array. The individual elements of the array are primitive types, which means we go back to our old case of passing copies. Anytime the things here are just straightforward ints rather than being an integer array, for example, all you're getting are copies. So I get copies of array sub 0 and array sub 1, and I go through this little exercise where I swap them. So I have some temporary where I put one of them in, then I take that one and I replace it with the other one, and then I assign the temporary back to the other one. It's not a big deal how it actually works. As a matter of fact, let me just draw it for you how it works so you know how it works and we're all on the same page. I get x and y. They have values, let's say 4 and 5 to start with. I have some temporary. I start off by saying temporary equals x, so temporary gets the value 4. Then x gets y, so x gets the value 5. Then y gets temp, so y gets the value 4. And for all intents and purposes, it looks like I swapped the values. Good times. Now I'm done with this function, and this all goes away because they're all copies and they're all temporary and they just vanish and nothing has actually changed in the array because I passed the individual elements of the array, which are primitive types. So if you pass primitive types, even if they're individual elements of an array, you are still getting copies. If you really want to do the swap, the right way to do it is swap elements happy, because it will make you happy. What you do is you say, hey, I'm going to pass the whole array. Once you get the whole array, you've gotten a reference to the array. You can change stuff around in the array and it will persist. So you say, hey, I'm going to give you the whole array and I'm going to give you the 2 positions of the elements in the array that I want to swap. So when I actually do the swap here, I'm doing the same logic, except I'm actually doing the swap with values in the array rather than copies of values that are passed in as primitives. So this version actually works because I'm modifying the array itself. Okay, any questions about that? If they're objects, you're actually getting references to the object, so you don't need to do the same thing. It's just for primitives that you need to worry about it. So let me just run this program just to show you in its painful detail what it's actually doing. We're running. Oh, sometimes it's just so slow and painful. But at the end of the day, you know, we get the little warm fuzzy. So I want to do the swap example. And so the buggy swap, notice element 1 is still, or element 0 is still 1, element 1 is still 2. Happy swap, they've actually swapped in place because I passed the array, which was a reference. Okay? So any questions about that? If that all made sense, nod your head. Excelente. All right, so a couple more quick things. One quick thing. This is super minor. You'll probably never end up doing this in your life, but if you see someone else do it, you'll know what they're doing, which is you can create an array that's initialized with particular values you give it by saying int bracket array. So we have some array of integers, and rather than specifying new or specifying some size, I just say, yeah, this array actually has the values 2, 4, 6, and 8 in it. So inside braces, I put the initial values from the number of values that I give it. The values are separated by commas. It figures out, oh, this is an array of 4 elements. So let me create an array of 4 elements for you, stick in those initial values to initialize it, and you're good to go from there. You virtually never see this. But just in case you do, now you know what it's like. All right? So it's time for one last great topic. And this last great topic, I'm going to give you very briefly just enough for right now that you need to know to do your Hangman program. On Wednesday, we'll go through all this in excruciating detail. So if you're not starting Hangman before Wednesday, you're perfectly fine. You'll see way more detail than you need for Hangman on Wednesday. But just in case you were like, hey, Maron, yeah, I'm studying for the midterm, and right after the midterm, I'm totally pumped up. I'm just going to go do all of Hangman. This is what you need for part 3 of Hangman. So part 1 and 2, you already know everything you need to know. Part 3, there's this thing called the array list. How many people have already gotten to part 3 of Hangman, by the way? Yeah, just one person in the back. Did you read about array list yourself, or have you not done it yet? I can't hear you, but that's okay. If you've already gotten to part 3, you're so far ahead, you just don't even need to worry. It's good time. Just come after class. I'll give you all the chocolate you want. All right. So array list. Because these array things are sometimes bulky to work with, especially when you think about, oh, I need this effective size versus actual size, and wouldn't it be great if when I needed more elements, the array just grew for me. So I said, hey, I start off with no elements, and I read in like 5 values for midterm scores, and I kind of store that, and I say, that's great. Oh, I found these like late midterms somewhere. Well, there's 5 more I need to add. And the array would just come along and say, oh, that's fine. You know, you've been so good to me this whole time. I'm just going to expand my size to give you more space. Like, wouldn't that be great? You're like, oh yeah, that'd be so good, like the birds would be singing and everything. But real arrays don't do that. Yeah, sorry, birds all been shot down. Array lists bring the birds back to life, and now they're singing again. It will do this for you. So what do you need to know about an array list? First of all, what you need to do is you need to import java.util.star, because this thing called an array list comes from the Java util package. Okay? Once you do that, you get access to our friend the array list, and the array list, as it's described in the book, comes in two flavors. It comes in the super cool Java 5.0, also known as Java 1.5, because sometimes the numbers for Java is 1 point something, like 1.x, and sometimes it's just x, and it's super confusing, but that's the way it is. So Java 1.5 is the same thing as Java 5, and you're like, that makes no sense at all. Yeah, it doesn't. That's just the way it is. So there's the super cool Java 5.0 or later version, and then there's the, yeah, still kind of useful but not quite as cool pre-Java 5.0 version. And the only thing you need to know is the super cool Java 5.0 or later version. So you don't need to worry about the pre-5.0 version. So in the super cool 5.0 or later version, an array list is something called a template, which means when I'm creating an array list is actually a class that I specify the type that that class is going to operate on, which is kind of a funky thing. But the way I declare an array list is I say array list with capital A, capital L, because this is actually a class that exists inside Java util.star. And then I use essentially the less than sign, or what we sometimes refer to as angle brackets if we're not using it as a less than sign. And then the type that I want to store in this array list. So essentially I want to have an array list of strings. And you can kind of think of this almost like an array of strings, but cooler. And so this is inside the less than, greater than signs. Okay? Then you give it the name. I might call this str list for string list. And then I say that is a new, and here's where the syntax gets kind of very funky, array list, angle bracket, string, close angle bracket, open paren, close paren. And you look at that and you're like, what? Why would I do that? That's just the way the syntax is. What this is saying is I'm going to have an array list. What am I going to store in the array list? I'm going to store strings. What's the name of my variable that is that array list? It is strlist. So that's the name of the variable. The type is an array list of strings. Okay? Once I set this up, all I get is my little space for a strlist. And so I need to actually say, hey, create the new array list for me. What kind of array list do I want? I need an array list that stores strings. I'm calling a constructor that takes no parameters. So I still need to specify an argument list for that constructor, which is where the open paren, close paren comes from. So the name of the constructor, the way you can think of it, is actually array list with the type specified, as funky as that may seem. And then the parameters are nothing. Okay? And so what this now gives me is strlist points somewhere in memory that stores my array list, which is some object that's going to store strings in it. Okay? How do I use that? Let me show you a real quick example. So because an array list is an object, it has methods on it. Okay? One of the methods I can do is I can say strlist.add. And what add does, I would give it some string. So I might have some string line that is hello. And I add line. What the add method does is it adds that element to the end of the array and grows the size of the array by 1. So if I want to add a whole bunch of things to some strlist, I start off by creating a strlist which is empty. So when I do this, I get an array list which is empty called strlist. And as soon as I do this add, whoosh, it grows to size 1, and it now has the line hello as the first element. If I were to do another add, like say strlist.add, and maybe I say there as another string, whoosh, it now grows to size 2, and there is the second element. So add adds, it appends to the end and grows the size by 1. Some other things I can do with strlist, I can ask strlist or array lists in general for their size. So there is a method called size, open paren, close paren. What this does is it gives you back as an integer how many elements are inside your strlist, okay, based on how many you've added. Okay? Another thing you can also do is you can say, well, it's great to be able to add all these elements, Maron, but how do I actually get information out of my array of strlists? What you say is strlist.get dot get. So there is like getter, much like there's a setter, and you pass it an index, I. And so what this says is get the element at the ith position. So if I've added line here, which is hello, that's at position 0. When I add there, that's at position 1. You can think of it an array that's just dynamically growing as I add more stuff to the end. And the way I refer to the individual elements is with get, and I still specify an index that starts from 0. Okay? And this is pretty much all you need to know to be able to do part 3 of Hangman. And you'll see it in much more excruciating detail on Wednesday. But that's all you need for now. Any questions about array lists? Alrighty, then good luck on the midterm. I'll see you tomorrow night.